without further ado, let me just introduce the panel. Over here on my far left is Dr. Ed Lu, who spent over 206 days in space during his 12-year career as a NASA astronaut, including 6 months on the International Space Station. He's a former Google executive and currently the chief of innovative application at Liquid Robotics in Silicon Valley, and is chairman of the B612 Foundation, a nonprofit dedicated to locating and deflecting asteroids whose impact threatens Earth. Lindley Johnson retired from the United States Air Force in 2003 after 23 years of active duty working on a variety of space program-related assignments. An expert on space control and surveillance systems, he was NASA's program executive on the Deep Impact project, which delivered a probe to Comet Tempel 1 in 2005. Now he works as a program executive for NASA's Discovery program of solar system exploration, as well as the Near Earth Object program. And he has an asteroid named for him, Asteroid 5905. So I'd like to start out, we'll go into that story a little bit later after we get some of the tough stuff done. We'll need to relax because you're going to be really, really worried. Let's start by getting an assessment from each of you of the danger that we actually face from rogue astronauts or near-Earth objects.
Astronauts. There's one right here. Hey.
That too, and you know, I'm sitting so close to one that I'm really nervous, that could threaten us here on Earth. And what I want to know is, on my bucket list of concerns, where does this need to fall?
Asteroid impacts come from big to small. At the small end that I think we're concerned about are the ones that might only destroy a city. At the large end, you're talking about ones that could destroy, all of human civilization. Now, they are rare, but that doesn't mean you can ignore them. So I wouldn't put them up there with, paying your mortgage this month and that sort of stuff. Everybody needs to do that. But somewhere, someplace, somebody, people like Lindley and so on, need to think about how do we protect the Earth, because it's one of those things that's global in nature. Very few things can be this global. And the risk, while in any given day is small, the odds that the odds are that you can't, in fact, you can never beat the house forever, right? In some sense, we're playing a giant game of cosmic roulette, and eventually you're going to lose. So the real question is not can we stop an asteroid from hitting us. The question is, actually, we know we can. The question is, do we have the will to stop one?
Lindley, why don't you take that on? What dangers do we face?
Okay, well, actually, I think I have a slide on that. PowerPoint number 5 or something like that. But it's certainly not an everyday risk. It's of something impacting and doing damage at Earth's surface. Of course, we get hit every day by meteoroids. In fact, the Earth accumulates something like 100,000 tons of material a day in fall from space. So it's a natural process, the impact. It's what built the planets. Everywhere we look in the solar system, we see impact craters. So it's a very natural process. Fortunately, though, it's a very rare process in human lifespans. And we might get hit with something significant every few hundred years. The last one of quite a bit of significance was the Tunguska event in 1908. Blew down something like 800 to 1,000 square miles of Siberian forest. Thankfully, it was Siberia. So nobody got hurt. But if that were to happen in a metropolitan area like Washington, D.C. or the Los Angeles basin, it would pretty much wipe out the city. So it's one of those very rare but high consequence events that deserve some attention to be able to counteract it. I think now that we are in this era that we have the ability to find these things and predict when they're going to impact the Earth, that we should do that so that we know if one is coming. And also with the space technology we have now, we have the ability to do something about it. It's probably one of the few major natural disasters that we think we can actually prevent if we know about it far enough ahead of time.
So let's go back to basics here, because I think like most average people don't wake up in the morning thinking about an asteroid coming in from the heavens and hitting them.
I do.
So let's.
You?
Yeah, well.
Well, I get a report every morning
I'm
of what the
worried.
night's catch is.
2 out of 3.
I'm worrying about my mortgage. I don't know. So let's do a little solar system geography. First of all, do we have a map where these things are? Where do they come from, and where are the dangerous ones?
Let me show a quick video. It is the location of all the known asteroids in our solar system. And these are accurately plotted. We've used the database from NASA. The outer ring of that is the asteroid belt. And that lies between Mars and Jupiter. The light blue line that stands out, that's the orbit of Earth. We don't really so much care about the asteroid belt from the point of view of those asteroids don't hit the Earth. It's these other ones inside. There's 10,000 of these ones that have been discovered so far that are called near-Earth asteroids, and they're the ones which occasionally run into Earth. Okay, and it looks like a lot. It looks like a crowded place. It looks like the Earth is flying around in a shooting gallery, and it somewhat is.
Thankfully, that's not the scale.
Yeah, and this is not the scale, obviously. The reason you have to make the dots brighter in order to see them. So, but the interesting thing is that of those asteroids that we're talking about that are large enough to wipe out a city, there's really about 1 million of those. So we've only really found about a little less than 1%. This is really what the solar system looks like. If you were to plot where the locations were of all the asteroids that could destroy a major city, okay? And so that's our real goal. How do you find all those? How do you track those? And so we can know in advance which one of those is going to hit the Earth, because we can actually prevent that, as we'll talk about.
So let's go back in history for a second, because you mentioned Tunguska in 1908 in Siberia, and as I understand it, we were just lucky that there was a lot of forest there and there weren't people, because otherwise it would have been very destructive.
Yeah, 3 hours later it would have impacted in the Moscow area and changed the entire history of the 20th century.
And we know on February 15th, there was an asteroid, a meteor that exploded over Chelyabinsk in Siberia. I don't know what it is about Russia. Is it like some magnetic force?
They have a large land area, so of course they're going to get hit more often than other countries.
Plus bad luck.
But right here, we have Meteor Crater in Arizona, and of course there's a crater not far off our coast for the impact that killed off the dinosaurs. So to give us a sense of perspective of how bad it can be, can you just discuss these historical events that we actually know happened?
Actually, could I have my PowerPoint slides up here for a minute? Here's a map of Earth's surface where asteroid impacts, impact sites, craters, have been verified where the Earth is. We know that an asteroid hit there because we see the impact effects. And you mentioned the Chicxulub crater that's off the coast of the Yucatan. That's the one that they thought killed the dinosaurs. So far we've found 184. We know there's a lot more. There's a lot of the Earth's surface, land surface, that hasn't been explored for these yet. But 70% of the Earth's surface is water. So most likely it's going to be the water that gets hit.
And what would happen if it were the water?
Well, depending on the size of the object, something over 100 meters in size, plunking down in the middle of the Atlantic, you're going to have a tsunami wave come up on both coasts, both the Atlantic seaboard and the European coastline. That could be 20, 30 meters in height.
By the way, the tsunami that we saw in Japan a couple of years ago, which you remember caused something like 1/4 or a 0.5% drop in world GDP that year, that was 3 to 4 meters. Mm-hmm. So full scale. Yeah.
Here is the Barringer crater, which you mentioned in Arizona. And if you ever get a chance, you're going between on I-40 between Winslow and Flagstaff. This is about 3 miles off of I-40, and it's a really impressive sight to see. But it's not something you want to have happen in your backyard, because even though the size of the object was estimated to only be about 50 meters in size, the energy released by that impact was something like 10 megatons, and created a crater that's about 1 mile across. That was 50,000 years ago, but it's something that could happen next week unless we find the objects.
Can I put that in perspective? 10 megatons, it sounds clinical. or 5 megatons. Let's call that 10 megatons. Just to put that in perspective, you've all seen the images of the bomb dropped over Hiroshima, right? And there's a famous picture of the remains of the buildings. That was a very small bomb. 10 megatons is about 700 or so times the size of that bomb. Okay, so this is a truly big explosion. Okay, they're rare. This type of thing might be about once every 1,000 years. If you look a little smaller, something that would only destroy, say, the LA basin, maybe 3 megatons or so. That in any given person's lifetime, let's call it your children's lifetime, there's about a 30% chance of something that size hitting somewhere randomly on the surface of the Earth. Okay, and as you know, most of the Earth is unpopulated. Not all of it, less and less so. And the real question really is that something that we find acceptable, or should we do something about it? Again, once every 300 years, which translates to about 30% per century. Let me just sort of flip the tables on that. What if I told you that there was a 30% chance that one of our missiles would accidentally go off and explode somewhere on the surface of the Earth, one of our very larger nuclear weapons, a couple of megatons, and blow up somewhere on the surface of the Earth? 30% chance of that. What would we do to prevent that? I think we'd move heaven and earth to prevent that. And this is sort of the natural equivalent of that. In some sense, it's a little bit different because there isn't a person that's in charge of controlling the nuclear weapons, right? This is a natural process that just happens. And the real point of this discussion, I think, is who's responsible if we're all responsible.
So let's take that question. Let's start with you, Lindley, since you work for NASA, our government. Whose responsibility is it to protect us against this threat?
Well, let me tell you what NASA is doing to protect against the threat. NASA's Near Earth Object Observation Program started in 1998. Initially, we were going after the 1 kilometer and larger objects because that's kind of a threshold at which we believe there will be global consequences from the impact.
You should define global consequences.
Whether around the Earth would
the end of all of us.
Be effective. No, not a 1 kilometer. But
it wouldn't be good.
It wouldn't be good. It would not be a good day. I would agree with you on that.
Our society would not look like it does today. Let's put it that way.
Yeah. So obviously, we wanted to ensure that there wasn't anything of that size out there, and so we were able to achieve 90% of the population by the end of 2010.
But those are very big.
Oh, those
asteroids.
are extremely big.
Unusual and very rare. So
now in the meantime, yeah, you might get an impact of one of those maybe once in a million years. Yeah. Since then, we've also they've moved the goalpost on us, and we're now searching for the 100-meter class asteroids. And
in feet, that's about 300 feet?
About 300 feet, right. About the size of a football field. Size of a football field. For the program, we're using ground-based meter-class telescopes, meter size mirrors. And those systems were very good at finding these larger asteroids. But to go down to 100 meters in size is a bit of a challenge. They have to come close enough. They have to come closer to Earth for us to be able to see them. So it will take a lot longer to find all those down to 100 meters in size. It took us, almost 12 years to find the 1 kilometer and larger. It'll probably take us at least 10 times that long to find the 100-meter size ones with these kinds of systems, because we've got to wait for them to come close to the Earth.
So Ed, whose responsibility is it to protect us against this threat, and is NASA doing enough?
Well, NASA's trying their best. Lindley's doing his best with his, frankly, limited budget. We at the B612 Foundation realized that at our current rate of discovery, given that there's about 1 million asteroids out there, and we're finding about 1,000 a year, we're using those telescopes that we found. If you could keep this up for 1,000 years, you could find 1 million asteroids. And we felt
1,000 years.
1,000 years.
Okay.
If you could keep that up, and it does get progressively harder. Now.
So it's almost like saying not doing it at all.
Well, no. They're doing the larger ends. The smaller ends are the city killers are much harder to find than the 100-meter ones. 100-meter ones is
to find the smaller ones. We have to improve our capability. There's no doubt about that.
Yeah. So what we decided is that because we knew how to find these things, and this is a subject of a lot of study. In fact, the National Academy of Sciences wrote a report about how you would actually find these things, and they basically said you need to use a space telescope to find these large numbers of asteroids. And you need to look in the infrared because asteroids are very dark. They're somewhat charcoal black. And because they're small, think of something the size of this room at a distance of tens of millions of miles. And it's very, very hard to see that, if not impossible, using ground-based telescopes. And so because these things are dark and they're warmed by the sun, they glow in infrared. So if you build an infrared space telescope, which is basically something like a huge set of night vision goggles, if you'd like, really huge, and you place this satellite in orbit around the sun, you can in fact find these smaller asteroids. So that's what our nonprofit foundation set out to do. And we're doing it in partnership with NASA, and we're doing it in partnership with the scientific community.
Yeah,
but
that's all based on studies that NASA has done as to what is the kind of capability we need to find these smaller objects.
Let me just press a little bit more on NASA. So as I understand it, NASA is funding a ground-based system that we all know is fairly inadequate to the task of finding the smaller asteroids. And in addition, as I understand it, Congress didn't even fully fund that effort. So this is a little hard to compute. Maybe you can explain it, Lindley.
Well, you get into the intricacies of the budget process, of the government budget process. The administration, first of all, has to propose a program to go do this, and to be able to propose a program, they've got to figure out how to fit it into the budget. And all the agencies have budget ceilings that they've got to stay underneath. All the agencies have priorities that are already on their plate that Congress has told them to do. You got to do these things, you got to do those things. So it's really a challenge to fit something new, a new program, under that budget wedge. And then once that budget goes over from the administration, then Congress, gets to rule on it. An administration proposes and the Congress disposes, as they say.
But the Congress wanted you to do it, they just decided not to give you the money to do it, is that right?
In so many words, yes, but it also takes an initiative by the administration.
How unusual.
Also takes initiation by the administration to actually put it in the budget in the first place. And they have, it hasn't risen high enough on the priority list of what NASA's doing for there to be a New START program for it. Now, we're slowly moving in that direction. NASA just recently, last week as a matter of fact, announced this new asteroid initiative as a grand challenge. And the grand challenge is to find all asteroids before they find us and know what to do about them in the next 10 years. And NASA is enhancing its own programs, first of all ground-based, but as Ed mentioned, we're looking at private-public partnerships, one of which is the B612. NASA has signed up to an agreement with B612. If they come with the spacecraft, NASA will supply, first of all, the technical support to help them develop and build the spacecraft, but also the telecommunications use of our deep space network to bring all the data back.
Those are antennas on the ground, by the way.
So actually, I'd really like Ed to now explain a little bit more. This is called a Sentinel spacecraft, right? Space telescope. Explain a little more about its infrared technology. What percentage of the bad asteroids will it pick up? How does it really work?
A good way to think about what we're doing. I want to back it up a little bit. First off, why are we called the B612 Foundation? Everybody always asks me that. And it comes from a book, which was one of my favorite books when I was a kid, which is called The Little Prince. And one of my favorite quotes from that is, what is essential is invisible to the eye. And what I think he really means by that is, what he really meant by that is the fact that sometimes the most important thing isn't what you see around you in everyday life. It isn't what is obvious. So, maybe what is the most important thing to our planet, and we don't know. Maybe it's not the latest Hollywood scandal or the latest thing going on in, corporate scandal in New York or the latest political scandal in Washington. Maybe it's something that we're not thinking about that's a little bit sight unseen at the moment. And B612 is actually the name of the asteroid that the Little Prince lived on. So let me just back it up to sort of how we got started on this. We I gave a talk about a year and a half ago at my old employer at Google. And I was just talking about the state of the business right now, how the fact that we know how to deflect an asteroid because all you have to do is run into it with a small spacecraft in the majority of cases. But that you're defenseless against the asteroids that you haven't found yet, right? Because if you don't know where something is, you're like a baseball batter with your eyes closed trying to swing at a baseball, right? There's no way to deflect an asteroid if you don't know it exists yet. And at this talk, I described the fact that, well, we knew how to find these asteroids using an infrared space telescope, but we're not actually doing that. So here we are, if the Earth had been hit 100 years ago, as it was, that's just kind of bad luck. At this point forward, it's no longer bad luck because we have the technology to prevent it. It's poor foresight. And I was just lamenting that fact, essentially. And a guy came up to me at the end of the talk, and he said to me, he goes, oh, well, how much would it cost to build that spacecraft? And I said, well, the National Academy estimated that it would cost roughly $1 billion to build that spacecraft if NASA was to build it. And he goes, well, how much would it cost you to build that? And I said, well, probably less than half of that because we don't have the federal overhead, federal acquisition regulations. Anybody who's ever done business with the government, that was part of it, knows what all that means. But you could do it a lot cheaper in the private sector as long as you have to know how to do it. And he goes, oh, well, that's not that bad. He goes, why don't you just do it? And I said, well, I don't have $400 million. And he said, well, wait a second. I'm donating to the San Francisco Museum of Modern Art. Anybody here ever been to that museum? Beautiful place. Okay, my sister is actually the chief engineer on that. And they're building a new wing to that wonderful museum. That new wing, this guy said, he goes, oh, we're raising $450 million. It's now $550. To put a new wing on the San Francisco Museum of Modern Art. He goes, and in fact, at any given time in the United States, there's hundreds of projects of philanthropic that are about this size. He goes, and would you cost less than that? He goes, so you're telling me that if we can raise, the people of San Francisco can raise $450 million to build the wing of an art museum, you can't do the same to save the world? And I just stopped in my tracks. I didn't know what to say, and I said, well, maybe that's what we ought to do. I drove home and I called my compatriot, a guy named Rusty Schweikart, who was an Apollo astronaut, and I said, Rusty, let me tell you about this interesting conversation I just had. And we decided that, in fact, that's basically what we needed to do. So 1 year ago, we started on this project, a little more than a year ago. We went public with it about a year ago, started about a year and a half ago, and that's when I originally talked to you, Lindley, about giving the data away to the world, including NASA. And we started raising money to do just that. We're essentially trying to build the wing of an art museum. We're doing it through private donations, and we are looking towards a July 20th, 2018 launch about a SpaceX Falcon 9 rocket. We will launch this telescope inwards in the solar system. It's going to go into an orbit somewhere similar to the orbit of Venus, which, as you know, is interior to the Earth, so that our telescope can look away from the sun and scan the skies for these million asteroids.
So tell us, what are the challenges in getting private people to understand this threat and to kind of putting it on their own priority list of donations? How hard is it, and how are you doing as far as raising money?
Well, it's a challenge. It's unlike things like education, the arts, healthcare that people know about already. Okay, so the great majority of people aren't aware of the asteroid threat, and so there is an education process that needs to happen first. But amongst folks that we can tell our story to, when I sit down with a major donor and show them the facts and figures, I use the National Academy's reports, I use a lot of the NASA work, and we show what the situation is, and they show them the odds. And I say, look, what is the point of everything that we do if it's not to turn over this Earth to our descendants that isn't wrecked by something that we could have prevented? And I actually have, I would say it's more than half of our large donors. Once you sit down and talk with them, we'll donate, and typically in 5-6 figures to begin with, and they'll generally step up to more. So our biggest challenge is getting in front of enough people and telling our story. Far and away, fundraising is the biggest challenge, and it's a matter of numbers.
Yeah. But I'd like to say with the Space Act Agreement, NASA has committed to providing support to this project, And the American taxpayer, through NASA, the agency, we will commit. Our estimate is about $30 million. So I think the American taxpayer is already the biggest benefactor for the B612 Foundation.
So far,
And by the way, that's in services. That's that he's talking about.
But that's
but
the American
clearly
taxpayer
important.
has to pay for those
And
services.
it's clearly important because
it's the only way you get your
yes.
data back.
Yes, we don't want to reinvent the wheel. These telescopes, these antennas on the ground, are used already currently to talk to our things like our Mars rovers and so on. And we will transmit our data back through that same network. And so it's critical to our mission.
Ed, you've said several times, we know how to do it. And that's one of the reasons, or probably the main reason. It's not just that there's a threat, but we know how to respond to the threat. So that's very persuasive. Is this an established technology? Is this kind of a straight shot? Are you sure that this will work?
No interplanetary space mission is simple. Okay, so it requires very, very good people, the best in the world, to build any interplanetary space mission, period. Okay, so that being said, the team that we have is, I think, as good as any spacecraft team in the world. Primarily, they're all NASA veterans. They're the people who built the Kepler Space Telescope, the Spitzer Space Telescope. The people that we have overseeing it are people who have run NASA's Mars program, the last two heads of NASA's Mars program. The guy, Tom Gavin, who was the head of mission assurance at the Jet Propulsion Lab. So we have experienced people running this. We can do it.
It's based upon NASA experience.
Absolutely.
Not necessarily being done the way NASA would do it.
But yeah, Lindley, do you have some doubts about the technology?
Well, we are working with them in technical consulting. Some of their approaches we would do a little bit different.
You could say we're all friends here.
Yeah.
It's okay.
Some of the approaches we would do a little bit different. For instance, we have an IR detector system, which we've developed.
IR means infrared, by the way.
Infrared detector system, which we have spent a few years developing, which is basically ready to go. It's part of a proposal that NASA has to build a similar IR telescope. Although we would put it at the L1 point versus around Venus orbit, because it's easier to get the data back because you're always at a relatively nearer distance to the Earth and being able to get the data back. Whereas if you're on the other side of the sun, it's a little hard to get.
But these are quibbles between friends, right?
These are quibbles between friends.
This is down in the technical details, truthfully.
Yeah,
and
okay.
can be worked out.
We've kind of been talking now about detecting asteroids, which we all understand is extremely important. But once you detect one, how hard is it to predict the orbit with certainty and to know whether this asteroid has us in its sights and where it will land, and maybe it will just go to a harmless place? And what risk is there in it of taking an asteroid that's headed for Aspen and deflecting it so that it goes to Moscow with, fairly serious repercussions? So tell us about the whole deflecting issue.
So first off, you don't have that much control over where an asteroid goes. Okay, that's not a. You can only really move it. Let me go back to discussing how you deflect an asteroid. Okay, first off, you have to understand that we're going to find asteroids decades before they hit us, not days or weeks. Okay, don't think Armageddon. Think
if we do the job
decades.
right, we will find it
exactly.
decades.
Now, with decades
so
of notice,
much fun to think Armageddon.
Kind of a fun movie. By the way, the cost of making that movie is about half the cost of building our space telescope. So, just so you know.
Maybe you could ask them to donate some of their profits.
If they're out there listening,
from their
you
DVDs.
can contact us at b612foundation.org.
Or you can pay your taxes.
Yeah. Well, that may go elsewhere, Lindley. But let's call it 10 years of notice. The Earth is going to travel in 10 years about 6 billion miles, as will that asteroid, okay? So this is an incredible moving shot, but we can do this kind of calculation. We know how to calculate orbits. This is something NASA is very, very good at. We send probes to Pluto, to Jupiter, to Saturn. We know how to calculate orbits extremely well, and we've been doing it for 40 years.
Yeah, we can calculate the orbits out as long as we get enough observations on the object.
Yeah.
We can calculate out the orbits at least a century in advance. So the technology is there to do it. The trick is getting the observations in the first place.
So how do you keep an asteroid from hitting Earth 10 years from now, 6 billion miles of travel away, okay? The answer is really, since the Earth is a moving target, that you basically want to upset the timing. Remember, the Earth is only about 8,000 miles across. I'm going to do math in public. 65,000 miles an hour is the speed of the Earth. That means it moves a distance equal to its size in about 7.5 minutes, okay? So at a very rough level, you just basically need to arrive 3.5 minutes early or 3.5 minutes late to the collision point, and that asteroid has now missed the Earth, okay? So it's really a matter of upsetting the timing. And if you back it off and say, how much do I need to change the speed of an asteroid in order to make it be a couple minutes early or a couple minutes late at that intersection point, it's absolutely tiny. It's generally in the order of less than a centimeter per second or a few millimeters per second. That's about the speed of, somewhere between the speed that a snail crawls or a fast ant. Okay, so
if you do it enough years in
if you
advance.
do it 10 years in advance or more. Now,
Which you would have to do with a space-based system, but with a ground-based, you don't only see it days in advance, right?
Well, we're
Yeah,
talking
well,
about the deflection system,
yeah,
not,
so-
not the
Okay.
observatory
So-
to find it in the first place.
this mission that Lindley worked on and that was run by Ball Aerospace, or was built by Ball Aerospace in Boulder here, the same folks who are building our telescope, this mission called Deep Impact, all they did was they ran into a comet with a small, tiny spacecraft, just ran into it. And if you think about it, that's basically going to change the speed of, it's changed the speed of that comet. It will change the speed of an asteroid if you do it to a comet.
Actually, we didn't. We hit it in such a way we wouldn't change the speed of the comet.
Yeah, because you hit it sideways. But, well, actually, you know, you did give it a delta V. So in any sense, it's the same basic technique. There are other ways of doing things,
technology
but the technology
certainly
basically
exists to do.
exists.
Yeah, let me take you back for a second, because I think some of the people here may not, you know, honestly, to the average person, I think this sounds kind of nuts, that you're actually going to take an asteroid coming in and you're going to do something about it and be precise enough so you can actually send a rocket up to hit it. But we've done it before, right?
Yeah,
Not
this is
once,
space
but many
technologies.
times.
Yeah,
So can you just quickly describe
Well, the
those
Deep Impact
missions?
mission, we impacted that comet at 83 million miles. It was almost out at Mars orbit. So we definitely have the technology to do that kind of thing. You know, we have the technology with for instance, the Cassini mission. The navigators at the Jet Propulsion Laboratory, they put the Cassini spacecraft through the rings of Saturn, which is, I don't know, it's 800 million miles away, something like that.
Actually, they even landed a probe on one of the moons of Saturn. It's even harder.
And the Japanese actually even brought back pieces of a comet, didn't they?
An asteroid.
Pieces of
An
an
asteroid?
asteroid, yes. Yeah, the Japanese Hayabusa mission, and they're about to launch another mission in 2014 to do a similar feat on another asteroid. NASA, the Planetary Science Division, has a mission called Osiris Rex. Will launch in 2016, September 2016, to go to the asteroid, which we now call Bennu, 1999 RQ-36. Will reach there in 2019 and bring back a fairly large sample from that asteroid in 2022. But this is the kind of thing where you got to think in years. You know, this is not something that, you know, next year things are going to happen. This is a legacy project. This will take many administrations, constant
Or
will
if
from,
we can
from many
complete our
administrations.
funding, we'll do it and we'll be launched in 5 years.
So we hear sometimes about using
That's
a nuclear
still a couple
weapon to
administrations.
actually destroy the asteroid. What about that? Why would we
destroying
have
it?
to do that?
In general, it's a lot harder than it sounds because they're big. And depending upon how close that is to the Earth, that may or may not be a good idea because where the pieces go is a little bit uncontrolled. And in general, it's actually easier to deflect an asteroid.
So that's not even on the
yeah,
agenda.
Well, I wouldn't say that because until we know where all the hazardous asteroids are, we always stand the risk of being surprised by one that we didn't pick up enough years in advance. And so nuclear device, you know, packs energy, you know, 100 times more the energy than any other kinetic impactor or something like that. So if we don't have a robust observation program. We may not find it until a nuclear device is our only option to, first of all, try to, a standoff and try to blow matter off the surface so that it gives it a shove to the side. Or if it's a small enough object, we could probably disperse it enough so that it breaks it up into smaller pieces that then are handled by the Earth's atmosphere. The Earth's atmosphere, does a very good job of protecting us from objects up to 20, 25 meters in size. So if it's a 100-meter object and we can break it up into 10 pieces,
So I'm going to open it up to you in just a minute, so think of your questions. But now I'd just like to go kind of to a more personal take on this. So both of you have really kind of devoted, I mean, you're making this enormous effort at raising all this money, and as a person who works for PBS, believe me, my sympathy is certainly with you.
Well, there are people who have been working it for decades.
And you've really devoted, a good portion of your life to it.
And I'm a piker compared to some people that have spent, 2 or 3 decades. So
you have talked to me, at least, about a moral duty to do this. Ed, either you or other people have talked about this as an existential threat. I'd like you just for a minute to talk about the personal passion that really drives you to make something that most people really hasn't penetrated their consciousness, the centerpiece of all your very considerable and very capable efforts.
Go ahead.
Well, I'll go first. My history in this starts back almost exactly 2 decades ago. I wrote a paper when I was at Air Command and Staff College for an Air Force study that was looking at what are the future capabilities that we needed in space. And I proposed the topic of defending the Earth against impacting asteroids. Preparing for Planetary Defense was the name of the paper. And at first they laughed me out of the room. And my wife can tell you this story because she was there at the Air Force.
I think you called it to me the giggle factor.
That's the giggle factor, right. But right after I proposed that topic is when the comet Shoemaker-Levy 9 was discovered that impacted Jupiter then in July of 1994. So I'm probably one of the few people that can say that their thesis was saved by an act of God, because all of a sudden I was a visionary. I knew what the future was going to be, and so it then became an additional duty is forever assigned to me to try to develop the systems to find these asteroids before they are an impact hazard, and to develop the systems to then do something about it. I never dreamed it would take as long as it is taking to actually develop a robust capability. I tried to get the Air Force to do it to begin with, and Air Force Space Command certainly was interested, but the Department of Defense thought that was a little too far out for them, and they were worried about man-made threats, not natural threats. So it was a more natural thing for maybe NASA to be doing. So when I retired from the Air Force, I went to work for NASA, and the rest is history, as they say.
Well, so first you had to kind of fight the Air Force in it. Now NASA is not really as forthcoming as you would like.
I have to say, even with my NASA logo on my shirt here, that I believe the agency has kind of ducked this responsibility a little bit and not prioritized it as high as maybe it should be. After all, our estimates on what it would really take to find them is about $1 billion program over 10 years, more than just building the space-based telescope, which we estimate only to be about $600 or $700 million, even if we do it the NASA way. Which is not a large project as they go. That's only 1/8 of the cost of the James Webb Telescope, for instance. So.
And Ed, talk to us about what's driving you, what gets you up in the morning?
I was lucky to work at 2 of the greatest organizations on the planet, I think. NASA, which prides itself on thinking big, and Google, which prides itself on thinking big and on moving quick. Mm-hmm. And one of the things that Google taught me was to be impatient. Mm-hmm. And I simply couldn't take it anymore that there wasn't rapid progress when there could be. And the reason I left Google was to go do this. And I had sort of personal financial loss. And, you know, I look at the problems that our world has. I look at, you know, all these other things. I look at climate change, I look at poverty, I look at education, I look at, you know, frankly, wars and all sorts of issues and stuff. And these are problems that I don't know how to solve. These are problems that are very difficult to solve. And I think it's wonderful that people devote their lives to solving them. Now, the issue of asteroid impacts is slightly different than those because 1,000 times smaller. And the solution is primarily technical in that we kind of know what to do, all right? And we know what to do, we know how much it's going to cost, and the time is short. And so of all the world-changing problems out there, the world global problems, this is the only one that I personally know how to solve. So that's what I'm devoting my life to. And you know, it's to spread the word and trying to get folks to basically step up to the plate, right? You know, our chief fundraiser at the B612 Foundation is a woman named Karen Putnam. She's a wonderful lady. And prior to being with us, she was with Harvard Radcliffe, and prior to that, she actually raised funds for Central Park. Central Park is if you remember about 15 years ago, they renovated Central Park. They basically brought it out of the doldrums. I mean, it was falling apart. She led the group that raised the money to endow it and fix it up because it was falling apart. And she had to go around to people and say, look, you know, people would say, well, why isn't my tax money paying for this? This is a city-owned park, they should fix it. And she said, you know, the reality is our city has a lot of things that it can pay for, but it can't do this on top of the fact that it can't even pay its own firefighters and police and teachers. He goes, so you have a choice. You can either bemoan the fact that the city doesn't have the money to fix Central Park, or you can step up and solve the problem. And that's what she did. And that's what she's doing for us. And it's the same argument, really. You know, Lindley described this complicated situation in Washington. And you can play that game. And you know, God bless you and all the people there doing that.
You have to have patience and tenacity to play that game.
And we've just taken the opposite tack. Let's just try and, maybe the private citizens can lead the way on this. And let's just get started. And we have started. So our spacecraft, you know, the progress has been great.
Let's open it up to you after those statements. And wait for the mic, please, but I don't see where the person with the mic is.
Yeah,
okay, right over here.
Get the lights there a little bit.
At the risk of stating the obvious, this is a global, not a U.S. problem. Would you be good enough to describe where you haven't approached people like the G8 or the OECD, the idea embedded that approaching the UN is probably not going to move quickly enough?
Good straight man, because I had one side that I wanted to get to. Because I had one slide I wanted to get to, and to talk about what we are doing with the United Nations. And last week I was at the United Nations Committee on Peaceful Uses of Outer Space, where we've been working with the NEO working group for a few years now. And
NEO is near Earth object, that means asteroid.
Their work is come to a culmination here and developing an agreement between the member states of the committee on setting up an international asteroid warning network, which is an enhancement of the network that we already use. Our network is really international. We get a lot of observations from around the world. They all go into the Minor Planet Center, which is a central node for our network. And this would enhance and get other member states to contribute to that cause. And then a Space Missions Planning Advisory Group, which would be a forum for the space agencies to get together and talk about what deflection techniques and technologies could we bring together if we were to find one that was on an impact trajectory. We're also working with the emergency response and talking about impact disaster response. So, you know, we not see a relatively small one coming in, but it does impact like what happened in Chelyabinsk. So there is ongoing work within the UN and the Committee on Peaceful Uses of Outer Space.
And we have international donors. And if you think it's slow working with Washington, try working with the European Space Agency or the Russian Space Agency or the Chinese Space Agency or whatnot.
Let's get another question.
Okay, let's get the microphone down to this gentleman here. Okay. Why don't you stand nearby so you can just give it to the others?
I'm Bob Ross from Oklahoma City. Thank you all very much. But I want to get down to brass tacks. What happens? You know, situation, a year or two out, you didn't see this one coming. What do we do? And I see this nice little chart, but at least you've got a plan to help us. The government, I don't know if we do have a plan. But what would happen? Is there something in the White House that rings and there's a plan and the president's whisked away and we're all saved?
His plan.
What happens?
His plan is part of our plan. The Sentinel telescope will just be another observer, another asset that we have to detect these objects.
This thing is coming to the world. What are you going to do?
If you don't have a lot of warning, there's nothing you can do. That's the key.
That's not true.
Evacuate.
Well, hang on, Lindley. That is true. That is true, Lindley. If you have
Depends
a couple
on
of
the
days'
size.
notice,
It depends on the size of the object. Most likely, it's going to be a fairly small object. Anything over 100 meters in size, we've sort of seen well out. But we are working with FEMA and other U.S. government agencies. We have had impact emergency response exercise with FEMA already about getting the notification out and working with evacuation procedures if it's that near a term of threat. Not only with the U.S. and the U.S. government, but working worldwide with the UN forum here that we talked about. In, first of all, verifying and validating the data that this is real. We've got our act together, and we really do understand when and where this object is going to impact. And we work with an international forum in doing that. And then getting the word out to the member states and those nations that may be affected, as this diagram shows, so that they know what the effects may be and how broad an area they need to evacuate.
I mean, this is War of the World stuff. People are really going to panic.
I have a different answer to that. I think that we ought to find these things with decades of notice, not late term, and just prevent it. Okay? I think we're at that stage where we ought to be thinking prevention.
Let's get to the one.
Okay, where's the mic? Why don't we bring it over here? There's a question back there, which I can take next.
My question is really a variant of the one that you just answered. If the asteroid coming in is sufficiently massive, how do you get a massive enough particle to hit it and move it? Because after all, to launch any projectile, you want to make it as light as possible. Here, you're going to have to make it as heavy as possible in order to move it if it's a big astronaut.
Yeah.
How do you handle that balance?
Yeah, well, first of all, the number of asteroids out there that are larger than a kilometer in size, we pretty well have a handle on that population. We now have found over 95% of them. So there's probably only a few dozen out there that are kind of in exotic orbits, quite frankly. There isn't going to be anything that large, a kilometer or more in size, that we're not going to know about.
That's the answer to this question. You're not going to have a big asteroid come in.
Well,
No, it's not that we won't, but it's rare.
Yeah,
It's very much rare.
but I mean,
And-
Tunguska was not a kilometer.
No,
Right,
this is
so
small.
so
Fit
now
is
we're
rare.
working on the 100-meter problem, which admittedly we need more capability to be able to find those things out far enough ahead of time. But a 100-meter object is something of the mass and size where something like a kinetic impactor, as Ed was saying, if we pick it up 10 years in advance, we've got enough time to be able to change its velocity enough so that it's a miss instead of a hit.
The other thing you can do is you can launch multiple missions at it. I mean, if it's something very, very large, we can launch multiple nuclear weapons at it, okay? And the key is you're not limited to one launch. And if it really came down to a kilometer-sized thing heading at the Earth, I think we'd pull out all the stops.
But the first thing to do is find them first.
Yeah.
When we find
Amen
one
to
that's
that.
on an impact trajectory, I don't think I have to worry about funding for multiple space missions to go
Yes,
after it.
yeah.
Okay, I think right over here.
So my question is, obviously the amount of energy released in an impact is a function of two things, right? It's the size of the asteroid and the speed in which it's traveling.
Mainly it's the velocity.
Velocity. So that's my question. How much variation is there in velocity between these objects, and how? I know they're all moving really fast, but how much does that impact the energy release?
Yeah, relative velocities of the asteroid population of the Earth go from 2 kilometers per second difference all the way up to 40 kilometers
But that's
per
on a
second
deep space.
distance.
When they hit the Earth, their velocity range isn't that big because they've fallen down towards the Earth. So there's a minimum speed that you would be going when you hit the Earth because of the fact you have to fall in.
Isn't it also the angle with which
It does make a difference, but essentially there's really,
For
most of these
smaller
asteroids are
sized
going to hit
object, the angle
between
does make a lot of
10
difference.
kilometers per second, so something like 20,000 miles an hour and about 40,000 miles an hour.
And most of that, or a lot of that's from the gravitational.
A lot of it is.
Okay.
yes.
Of the
Well,
Earth.
that's just the speed at which things go around the solar system.
Yes, and then you add, those two get combined.
Okay, other questions? There's one right here. Right over here.
So basically they would hit us at a really high rate of speed.
I have a question for Lindley Johnson. You mentioned that you feel NASA perhaps has shirked its responsibility a little bit in this area, but you also, when you introduced the Grand Challenge, said that NASA plans to enhance its ground-based programs. Is that part of making up for some of that responsibility?
Yeah,
and what are the enhancements that you are you going to do?
Currently, we're trying to step up our game a little bit, put a little more money into enhancement of the ground systems, bring on some additional ground assets, and then looking at partnerships, one of which is B612, frankly, and with other space agencies around the world to maybe get to space-based assets. We're, see how it all develops. It's just started last week. We are looking for responses from the broad space community and the observer community about what more can be done.
Okay, more questions up here in the blue shirt?
I guess I have a question for each of you. It's related, though. Starting with Ed, you said you could put a kinetic impact 10 years in advance and deflect it enough.
If you knew about it. Yeah, if you knew the asteroid was,
if you knew about it. Yeah, assuming you know about it. But my understanding is that, let's say it's not that big, 50 meters, 100 meters, still very dangerous to Earth, but if you cause it to break up, you could end up with several objects, one of which could still hit the Earth and might be large enough. And I'm trying to understand, so you don't want to hit it too hard, or what are the dynamics here?
There are other ways of deflecting small asteroids, including things called gravity tractors, which basically tow them slowly. So at the smaller end, there are more options. At the larger end, gravity tractors are not going to work for what's called a primary deflection. You do have to be careful not to break up an asteroid. That's
Let me recommend over here at the planetarium, they're showing the short film Cosmic Collisions, and it talks about these kinds of things in that short film.
A follow-up question for you is that you're talking about using nuclear weapons, but isn't that, if it's a much bigger object, but isn't that even a bigger problem? You're going to just break it up and still going to get hit by something pretty big?
Well, it will all depend on the dynamics. You have to do that at the right time, at the right place. What I have found in looking at the deflection dilemma, if you want to call it that, is it's really scenario dependent. It depends on what orbit the object is relative to the Earth. What is the object composed of? Is it a solid rock, or is it what we call a rubble pile? It's a bunch of stuff that's stuck together. And before we would do a deflection demonstration, and another reason why you want to find them well in advance, we would send out a precursor observation spacecraft to really figure out, what does this thing look like? How is it composed? And so to determine what really is the best method to try to deflect this object.
Okay, more questions? There's one right over here.
So one question I think the Department of Defense might be interested in. It seems to me if you can figure out how to deflect an asteroid that might hit the Earth, you could also figure out how to arrange an asteroid to hit the Earth.
Can I take
Here
this
it
one?
comes.
Can I take
Go
this
ahead.
one? It would be, I call it the world's stupidest weapon. Because, first off, you don't get to choose when you use it. You need to have an asteroid that's already coming close to the Earth. And because of the way orbital mechanics works, you generally only get to move it up and down along one particular line. And that's because it's the line that it's already taking where the Earth goes through it. So you don't get full control over it. And I make the claim that if you have the technology to find and track asteroids and deflect an asteroid into a location of your choosing, you have a lot better ways of attacking your enemies. Far, far, far easier at the time of your choosing. I cannot think of a more stupid weapon.
Yeah.
So I think we only have a couple more questions. Is there one up there?
Thank you. Wait, so sorry. What is a greater threat, nuclear weapons or asteroids?
Depends on whose hands they're in.
Yeah, I mean, nuclear weapons would be something that would be caused by our own doing, and I don't know how to calculate the probability of that. Asteroid impacts are a matter of chance, and I do know how to calculate the probabilities of those. And you know, and those odds are what so they're sort of fundamentally different.
But if you're talking about the energy released, asteroid impact by far.
Yeah, far larger than any nuclear weapon.
Yeah.
Okay, so were there any more questions? Oh, over here.
Yeah,
A
very
woman,
good.
yay!
The asteroid that was in Russia a few months ago,
Siberia.
did that literally fly under the radar, or did organizations know it was coming?
No, we did not know it was coming, mainly because it came from out of the sun, literally. It came from a direction that was only 15 degrees off the Earth-Sun line, so no Earth-based observatory could have seen it before it hit the Earth's atmosphere.
But Sentinel would have seen it, Ed?
Would have seen it depending upon how close it came to Sentinel. So Sentinel has the capability to pick up objects that are between the Earth and the Sun.
Yeah.
Mm-hmm.
Pretty
Right.
small object, though, for...
Yeah.
Over here? Okay.
What is the relative probability of being hit by a large asteroid versus from out of deep space, a comet?
Asteroids are about 100 times more common than comets. So they're much more numerous than comets.
You want to just tell us what the difference is?
Comets come from deep space out beyond the last of the planets, way out there. And they tend to come screaming into the solar system at high rate of speed, but they're a little hard to predict because they sit out there, they're cold, they're dark, and then they come in at a high rate of speed. So you're not going to get a lot of warning for one of those in general. Unlike an asteroid where you can see them because they're just going around the sun over and over.
Yeah, you're talking about Oort cloud comets. There are Jupiter family comets, which we see. In fact, we have 94 in our catalog right now that we're tracking. But let me make a pitch for a comet that's coming in this fall.
Go take a look.
It's one of these comets that come from deep space. It's called Comet ISON. It was actually found by a network that is managed out of Russia. And it uses a lot of amateur astronomers found out beyond the orbit of Jupiter. In the late November time frame, it reaches its closest point to the sun and whips around the sun at a very close distance. In fact, we wonder whether it's going to survive what we call the perihelion passage, or whether the sun will break it up. But if it does survive, it's going to be a spectacular sight in our skies in December and January.
So I can make a pitch now for PBS because we'll be doing a program on that comet, and we'll also on NOVA be doing a program that'll be on the same night at the end of November on this threat from asteroids. Are there any more questions? Did I get them all? I think we have one more minute. Would either of you like to make a final statement here?
I would, and it has to do with the odds and whether or not people can whether or not we should be paying attention to this problem. So I want to put the odds in perspective. Let's take a little large, sort of the 140-meter class, fits inside a football stadium, size asteroid. When one of those hits, and those hit the Earth with about a probability during your lifetime about 1%. That has an explosive energy of about 100 megatons. That's about if you took all the bombs used in World War II and multiplied by 5, that's roughly what we're talking about. Okay, so I asked you, and it's hard to see how that couldn't hit anywhere on Earth without global economic or political repercussions, or perhaps tens of millions of deaths if it hits in the wrong place, if we get unlucky and hits in the wrong place. So 1% is the chance that, let's call it during your children's lifetime, during this century. And 1% isn't that small. And I know I have to ask folks, do you insure your house? Right? What are the chances of your house burning down? Maybe here in Colorado it's a little bit different, just because we're in a fire zone here. But people carry fire insurance. Why? You don't have a 1% chance of your house burning down. Why do you carry fire insurance? Because it would be terrible for you if your house burned down, all right? Now I'm talking about something now for asteroids. Who's responsible for insurance for the world? Now I'm talking about something better than insurance because you are talking about preventing these things, not just cleaning up afterwards. We could prevent this. And what is that worth, right? 1%. Okay? And we're talking about an amount of money that's roughly equivalent to building a large freeway overpass or the wing of an art museum, okay? What is that worth? Regardless of where the money comes from, regardless of whether it comes from a government entity or whatnot, or if we raise the money privately. But I think that that's a decent investment on, with a great return, because in the end, you're talking about protecting all of this.
Well, I think that that's a very provocative question to
But
leave
I'll
us
be real
with.
short. I'll be real short.
Okay.
Real short. This is a subject of high interest in Congress right now. They've had 3 hearings over the last 2 or 3 months in debating what we're going to do with the 2014 budget. Talk to your congressman.
And I think we are all very lucky to have Ed Lindley Johnson on the case.